This is Miss Sutter. She used to teach here, what, 2 years ago, 3 years ago?
This would be the third year of retirement.
Okay. She's been retired for 3 years. She used to teach here. Used to be one of our math teachers. Algebra 2 was your forte?
Oh, I don't know if it's my forte, I taught it at the end. And,
Excellent resource. Excellent teacher also. Okay? So if you have any questions, don't hesitate to ask today. All right? 4.7, absolute value functions. Okay, now, what's the absolute value of a number? It's always going to be what? Positive. This is different. And what makes it different is this little word right here, functions. Okay, this is basically very similar to what we've been graphing, and that's linear or lines, right? Okay, an absolute value function is going to be the shape of a V. Okay, so it's a little bit different, but there's a lot of similarities. All right, did you guys get your objective written down? Okay, what about your math skills? Get those? Okay, good. All right, this is in your notes. Find this, because we're going to be making some notes on this. Absolute value functions is another type of piecewise linear function, is the absolute value function. Recall that absolute value of the number is always what? Non-negative. Basically, that means it's positive. Okay, so an absolute value parent function, written as f of x equals absolute value of x, all of the values of the range are non-negative numbers. Okay? Now, every graph, you guys look at me, listen, you need to know this. All graphs have what's called a parent graph. Everybody in here has parents, right? I have parents, we all come from parents. All graphs come from a parent graph, right? What's the parent graph for a linear equation? Anybody tell me? Parent graph of a linear equation, write this down. It's going to be y equals x. Okay? Now, you can add some things to that if you want. You can add a 1x, and then you could add a plus what? 0. So now, if I say y equals 1x plus 1, what happens to this graph? It moves it up how many? 1 squared. Does everybody see that? If I say y equals 1x minus 2, then it moves this down how many? 2 squares. Is everybody with me on that? So a parent graph is always a linear parent graph. Okay, it's always going to look like this. What's my slope? 1 over what? 1 over 1. So now, you understand the shift? It'll basically take this line and do what? Shift it up 1. So it takes this line and moves it up 1 squared. Does the slope change? Okay, if I say a minus 2, notice my slope hasn't changed, has it? Okay, if I go minus 2, then it shifts it down how many? 2 squares. Is everybody clear on that? Okay, what happens if I do this? What if I say y equals negative x? What happens to this line? It flips down. Everybody understand that? Okay, so if I say negative 1 plus 1, what does it do? That paragraph does what? It flips, and then it shifts up 1. Everybody understand what I'm talking about? Okay, so a lot of times you can graph lines just if you know the shift. Okay, it's another way we can graph. We've learned we can find x and y intercepts. We can use an input-output table. I can use slope-intercept form, or I could use what? This is what we call translations. Okay, that's basically what we're going over today. So what's the parent graph? If this is the parent graph of linear, what is this? This is the parent graph of what? Absolute value function. Is everybody clear on that? Okay, now, let's identify a couple things. You got f of x is the same as what? same as y. Okay, we say y is also our what? Output. You gotta write this stuff down, you're gonna need to know it. Okay, whatever's on the other side becomes my what? Input. Now, in front of the absolute value, that is considered still my what? Look. Now there's some things inside the absolute value that will kind of modify it or change it. We'll talk about that. Is everybody clear on that? All right. Also, if it's positive in front, my graph is going to face out, up. If it's negative in front, it's going to face it where? Down. All right? If it faces up, the vertex is called what? It's called a minimum. All right? Write that down. You're going to need to know that for algebra 2. It's called a minimum. If it's up, facing up, the vertex is called a minimum. Minimum means it's what? The lowest point. Okay? If it's facing down, okay, then it becomes a maximum. Okay, so facing down, vertex is, it's called maximum. Hard?
Yeah.
Have you tried the pointing? Try that. Okay, is everybody good there? Okay, now you have a handout that I just, Ms. Southern passed out to you. Find that handout. Okay, this is kind of an addition to what we're doing in our other notes. So basically I have two different examples today. This is the first one. Now, we can use translations to graph these, but we can also still use an what? Input, output table. We can still use that to graph line, or to graph it, okay? What do we use this for? To find what? Find points or inputs, outputs, right? We want to find points or ordered pairs. So, the first thing I need to find is where do I start from? Where I start from is called the what? The vertex. So here's how you do it. I'm basically, whatever's inside the absolute value, okay, I'm going to take it out and set it equal to 0. Write this down, copy it down. I'm writing, you need to write too. If I write, you write. Okay, so we can say the vertex is my start. That's where everything works from. Okay? Is this going to be facing up or facing down? What's in front of here? Is it positive? Okay, so it's a positive, right? So it's facing up. Okay, so how do I get x by itself? Add 4 to both sides, x equals 4. So, again, your vertex is an ordered pair, right? What's the first number? Is the x coordinate, right? Which in this case is 4. Now I've got to find the other half, which is what? It's y. Okay? Which is going to be what? 0. Now, how do I know for sure? I can always take this and do what? plug it in. Right, what's 4 minus 4? What's absolute value of 0? Everybody with me? Any questions? Okay, so now go to the next one. Find step 2, step 3. Is it at the bottom? Okay, step 2, determine the slope. We just did that, right? We said it's what? Positive, and it's 1 over 1, right? So that means I'm going to plot my vertex. Where's my vertex go? Over here, doesn't it? 4 and 0. What is my vertex? Is it a maximum or minimum? Minimum. So it means the lowest point. So my slope can go where? Up 1, up 1. Okay, now notice I just have what? One side here. Once we do that, we need to find the axis of what? Symmetry. The axis of symmetry is a vertical. It goes through what? The vertex, the minimum. So what I'm going to do is draw a dotted line right there. That's my axis of symmetry. Axis of symmetry basically means that I can take this and I can fold it over and I have what's called a what? A reflection. Okay? So the left side is going to be the same as the right side. Alright, so now what you can do is say, how far is this dot from the axis of symmetry? It's how many squares? 1. So on the other side, the reflection is going to be 1 square on the other side. How many is this?
2.
And then it's going to be 2 over here. How many is right here?
3.
And so it's got to be,
3.
now guess what you have? Connect your dots, extend your line all the way out to the edge. And there's my graph. I'm going to stay away from this, Alyssa. Guys got it? Now, something else I can do is I can just find points. This is on the other side, on the reverse.
Actually, there isn't anything on the other side.
Oh, it did print two-sided? Well, draw your input. Draw it 2 different ways. This first way is what? Go ahead and write. He got it. Wonder what happened
Some
there.
of these others have it.
All right, put your function down, and then this is this an input-output table? Okay. What kind? We say this is what? Remember, I told you on the big test that you have, the EOI, you're going to see it in 2 different forms, right? They love to show it vertically or horizontal. Okay? Is it the same thing? Same thing. So now, another way we can do this is I can find some ordered pairs or some points. Okay? What's the first thing that we need to find, guys? We need to find what? The vertex. That's where everything starts. Now notice, where do I put my vertex? I put it in the middle because I got a left side and I have a right side, right? So I'm going to put my vertex there. So to find it, how do I do that? Again, we take this in the middle, we take it out and set it equal to what? 0. Add 4 to both sides, so x equals 4. So when my input is 4, my output is going to be what? 0. Where would I put it on a horizontal input-output table? In the middle again. What goes on top? 4 and then 0. Now, I will just tell you, when we do absolute value, everybody prefers this horizontal table. Why? Because from here to here, that would be my what? Left side. From here to here, it would be my what? Right side. Is everybody with me on that? Okay? So if I go back to my graph over here, and I find my, what's the next number to the left of 4? What's the next number to the left of 3? Okay, what's the next number to the right of 4? The next number there? Now, do I need to solve this for both sides? What do we say? It's a what? It's a reflection of each other. So my left side is going to be the same as my... So now, again, my question, do I have to work both sides? I just need to work one side, don't I? You see what I'm getting at? Okay, so I'm going to go back to my original, f of x, x minus 4. What's the first number that I put in? What's my first input? I'm going to use 3. So 3 minus 4 is giving me negative 1. What's the absolute value of 1? Or negative 1. So 1 goes there. What's it going to be on this side? 1. It's the same thing. Right? Okay, do it again for 2. F of x equals 2 minus 4. 2 minus 4 is what? Negative 2. What's the absolute value of negative 2? So this is going to be 2, and this side is going to be 2. You guys see it? Okay, so my ordered pairs are what? 4 and 0. 3 and, I probably should do it over here. 3 and 1. 2 and 2. What is it on the right side? 5 and 1 and 6 and 2. Do those match up? 5 and 1, 6 and 2, 7 and 3, right? 3 and 1, 2 and 2. So do they match up? Okay, so you got a couple different ways you can do it, right? All right, let's look at this one. All right. This one, this type of problem, kind of throws the may draw on Miss Southern's expertise here. This one kind of draws a monkey wrench into everything. Okay, because I'm going to show you something here in a second. I'll probably let's go ahead and show you now. This is on the second page. You guys see this on the other page? On the other side? Okay, these are called translations of absolute value. Just like over here, when I added 1 to the parent function, what did it do? It moved it up 1. Same thing here. This is the parent graph. It's graphed in blue. Okay? If I put a negative in front of the absolute value, what's it do to it? Flips it down. Okay? Is my slope still 1 over 1?
Yeah.
Down 1 squared, left 1 squared, down, left. And then you use your what? Axis of symmetry, right? Everybody with me? Okay. The other one, so what's the square on there? Does it say it flips? Did I put that in there for you? Look at this one. Parent graph is in blue, right? If I put a negative 1 after the x inside of the absolute value, it shifts it how? It shifts it right, how many? 1 square. So you may want to say, I think there's a little space on there, isn't there? What do you say? Shifts what? Shifts right 1 square. Okay, notice it's negative 1. So it shifts it in the opposite direction, which is a right or positive 1 squared. You guys with me on that? Don't let that confuse you. If it's a plus 1, after the x inside, then it shifts out. Good. Shifts left 1 squared. Guys got it? If it's outside at the end of the absolute value, then it shifts out. Up 1 squared. Now, if that were 2, it shifts how many squares? 2. You guys get that, right? If it's a -1 and it's after the absolute value, then it shifts down 1 squared. Now understand, I could have a shift up and also a shift over, right, or to the right. I could also have a what? A flip down, a shift up, and then a shift left or right. Okay? All three of those things come into play. Okay, the last thing is this. If you have a number in front, this is a positive what? Positive 2, right? It's kind of like the slope. Right? So a positive 2 does what? It closes my absolute value. So it's greater than 0, right? So we'll say greater than 0 closes. If it's what can I say here? Is that greater than 0?
Yes.
Okay, so it has to be less than what? 1, which is a fraction. It does what? Opens it up, right? You guys with me? Okay. If both of those were negative, then it would do what? Flip it down, right? Close it up. Oh God. I have to go to the baseball field.
Sorry.
You're okay. Are you gonna be around today?
Nope.
Okay. I'm gonna go out there and get it. I got one space right up to the tire. I can go out there and get it.
Okay, so after my therapy, will you be back up here or will you be back?
I'm gonna walk out there and get him and bring it back over here. I'll be right here. Thanks. Okay, is everybody good? All right. So now let's go back to this one. Sometimes what happens is you get some things that kind of modify what's going on. Okay, this is one of them. Anytime you get a number, I will just tell you this, and I recommend that you do this. Anytime you get a number that's in front of the x like that, and still inside the absolute value, you need to use a what? Use a double T table. Everybody with me? It's going to be a lot easier, a lot faster to do it this way. Okay? So, that being said, what's the first thing that I need to find? Vertex goes where? Right there in the middle. That's my vertex. Remember how we find the vertex? Take this part in the middle and do what? Set it equal to 0. Subtract 2 from both sides. Divide by 2. X equals what? -1. Now, how would I find this? What can I do? Yeah, can I plug it back into the original equation? Okay, so I'm gonna say, I'll have some of those space here. F of x equals absolute value 2 times what? -1 plus 2. Okay, 2 times -1 is -2 plus 2 gives me absolute value 0. So my first point is what? Plot that over where? So it goes what? -1 and 0. I think there's a shift in there and there's some division in there. I'm leery about showing that to you just because it gets pretty confusing. I think it's probably better off if you guys learn that next year in Algebra 2. Wouldn't you agree?
Yeah, in fact, in Algebra 2, we didn't graph that many that had the coefficient of x inside there. I mean, we did a few, but it's not very common.
What happens right here, and the reason why I showed it to do it like this, it's just the easiest way to do it. You can make a shift to the left, and then you have to divide by 2, which kind of modifies my shift in a certain way. And so it gets pretty complicated. If you just do it like this, like I'm showing you, then it takes all the complication out of it. It's still the same thing, all right? Just takes all the complication. What's the next? Now, I use a vertical table, so I'm going to consider this my what? My right side. And you may want to pencil that in. The top, anything above is going to be my right side. Anything below is going to be my left side. But am I worried about that? Hello? Aaron, am I worried about that? You may want to pay attention, okay? It would help, or you're going to be confused. Am I worried about working the left side? I'm already have that done, won't I? Okay. So what's the next square to the right of -1?
0.
What's the next square after that? 1. Okay, so I'm going to plug my numbers in. 2 times 0 plus 2. What's that give me? Okay, so my next point is 0 and 2. And then do it up here. And understand it's still absolute value, isn't it? Let's do this real quick. What's this going to be? If this is 2, what's this? 2. What's the next number to the left of -1? -2, and then -3, right? Okay, see how I'm doing that? Okay, so 2 times 1 plus 2. What's 2 times 1? Plus 2. What's absolute value 4? So my next point is 1 and 4. What's this going to be? What? 4. So you got -2 and, no, 2, isn't it? And then -3 and 4. What are my points? 0, 2. 1 and what? 4. Okay. -2 and 2. -3 and 4. Okay, so not only did it shift 1 square, what happened to it? Closed up a little bit, didn't it? Even though it looks like in front my slope might be 1/1. So it modifies it a little bit, okay? You have to pay attention to that. So again, follow the rule I just said. What was the rule? Anytime you got a number in front of what? X that's inside the absolute value, what do you need to use? An input-output table or double T table. Everybody clear on that? So it needs to be the first couple things that you check. If you don't have anything in front of the X, what can I do? Use what? Use translations to move it, right? From the parent graph. Is everybody clear on that? Yes, no? Okay, you gotta talk to me and communicate. Any questions beyond this point? Okay, let's go to pair check. First two columns on the front. What's in front of the X? Okay, so what can I use? Can I use translation or what do I use a double T table? Use translation, it's going to go faster, isn't it? So now what would my parent graph be? Well, where's my vertex? It's always going to be what? 0. And then one square there, one square there, one square there. There's my parent graph. The same thing on the other side, right? This is what all graphs grow from or stem from. So now this plus 1 inside, what's that going to do to my parent graph? To the right, so it's going to be a shift. So this point right here shifts where? Right 1. This point shifts right. This point does what? Shifts. This point shifts. This point here shifts to the right 1, and there's my new graph. See it? Any questions? Okay, look at number 2. What happens here? What's in front of the X? It's a negative 1. So is there something in front there? Okay, so what do you need to use? Use your input-output table, right? And I'm the same space in the middle right here for my what? I'm going to leave space right there for my vertex, right? How many do you guys like the horizontal or the vertical? Like the horizontal better? Well, I mean, it's left side, right side, isn't it?
Yeah.
Okay, I'm going to put that for my what? This is going to be my vertex, isn't it? Hello, am I up there? Okay, so negative x plus 2, set that equal to 0, subtract 2 from both sides, divide by negative 1, x equals what? 2. Plug it back in, so negative 1 times 2, that would be negative 2 plus 2, which is 0, so it's going to be 2n, 0. So 1, 2. What's the next number to the right of 2? Next number to the left of 2. And now, me personally, what side would you guys rather work? Left side or right side here? Huh? I'd do the left side. Is there any rule that says I have to do one over the other first? Because it's still going to be what? The same, right? Okay, so the left side, I'm going to do 0 and 1. I just like simpler numbers. I don't know about you guys. Okay, that's negative 1 times negative 1 times 0 plus 2. What's that give me? 2, doesn't it? Negative 1 times 0. Okay, so this is going to be what? 2. Negative 1 times 1 plus 2. What is that? 1. Negative 1 times 1 is what? Plus 2 gives me, what's the absolute value of 1? So what's it on the other side? This is 1, this has to be, no, it's the same, guys.
1.
If this is 2, then this has to be 2. So now plot your points. 1 and 1. And then 0, 2, that's my left side. right? That's this side here. My right side is gonna be what? 1, 2, 3, up 1. 1, 2, and then up how many? I'm sorry, 4. 1, 2, 3, 4, up 2. Pretty simple.
You never get away from the chart totally. You never get away from the two-chart totally, it's always consistent.
It's always useful in anything you do. Any graphing, anything graphing wise. Okay, was there 3 on there? Translation or input output table?
Translation.
Good, nothing in front of the X, right? So my parent graph is gonna do what?
Shoot to the left.
It's gonna go,
Right.
no. Is it inside or outside? Okay, so
Oh,
look at your notes.
oh.
No.
Down 3.
That's minus, so it's gonna go down 3. I think you guys can do that one, right? So my vertex goes where? Start at 0, goes 1, 2, 3. Up 1, right 1. Line of reflection. Or axis of symmetry, rather. Am I saying that right? It's a reflection, isn't it? Yeah.
Oh, yeah.
Okay, translation or input output table?
Translation.
Going to do what?
Shift to the left.
Very good. I think you guys got that, don't you? Okay, so look at the other half of your. Look at the other half of your pair check on the other side. Translation or input output table?
Input output. Input output. Input output. Input output. Input output. Input output.
What would the domain of any absolute value be? Remember, domain is what? X's? So what are my graph, what's my graph doing? What does it keep doing? No, it keeps widening, doesn't it? So all my domain would be what? All real numbers. Because it's expanding left and it's expanding to the right. Even though our graphs stop at a certain number, it still has arrows. So what does the arrows mean? It's still doing what? It's still expanding, right? Okay, what about my range? Whenever you had a minimum or a, so my range is all my, how much is it going up or how much is it going down? So if you have, if I have a graph like an absolute value like this, where's my minimum? Okay, so can I count all the y's that are below that point? No, it's not part of the graph, is it? Okay, so I would say all real numbers greater than what? What's that? -2, right? So my range is all numbers greater than -2. What if we're facing down? It'd be all numbers less than whatever the vertex was. Everybody clear on that? Range is my what? My y's. Domain is my x's or my inputs, right? Everybody understand? Hello. Hard to tell. It feels like I'm talking to zombies. Got some zombies out there. Too many zombies.
Wow.